64, minimum path sum. Given an m by n grid filled with non-negative numbers, find a path from the top left to bottom right, which minimizes the sum of all numbers along its path. You can only move either down or right in any point in time. Okay. I feel it feels like I've done this before. Is either that there are many similar problems. There are many similar problems on Leetcode that are the same. Hey, what's up, Dunkin' Donut? Nice to see you. Yeah, I mean this is my regularly slotted time, so it's the one day a week I try to at least keep it consistent, which is on Sunday 9 p.m. Eastern time, at least for a little bit. Um, yeah, I mean I think this is straightforward, but there are a couple of ways to think about this. One is the dynamic programming, but because there's a very innate DAG that comes with it, but you could also kind of think about it in terms of a breadth first search or something like this, because, um, but it's the same idea really, which is the core idea is that because it is a DAG, DAG being meaning is a directed asynchronous graph. That means that a lot of things are a lot easier because you can only go down and right, so you never need to kind of like you never get into a cycle, which is what asynchronous means. So we could definitely do that, and I'm gonna try to do that, and it's good practice, I suppose. So yeah, m by n grid. Okay, I think one thing that I've been trying to be a little bit better about is just use I feel like I get confused with n and n's and m's all the time, and it leads to some mistakes. So I'm trying to be a little bit better and just call them rows and columns. And I guess I have to check that if they don't tell you, return I guess 0. I don't know. Could be -1 maybe. I mean, well, not in this case because they don't tell you, but in theory, it is just a random number. Okay. And then now let's construct my hesitation is like, okay, do I want to do it in place or do I want to create an explicit array? I guess in this case I could just do it in place. So so let's do it. Our ending condition is going to be something like this. Oops. And then now we can just go through the array. So the one caps. I guess it doesn't really matter. I need to be consistent though, because now I'm using caps in one place and not in the other. Okay, fine. And then now grid of RC is equal to the min of min of something like this. Plus grid of RC, and that should be technically okay, but we have to handle the edge cases, so that's why it's going to be a little bit weird. Oops. The edge cases of R is equal to 0 or C is equal to 0. I guess for this I'm okay with just kind of doing. Let's just call it best is equal to none. Whatever. Let's just go at 0. Okay. Yeah. Best is equal to this thing, really, which is the 99% case, or the majority of a case. And you could, and sometimes if you don't do this in place, you would construct, like a boundary around it, so that makes it easier, and that's how I usually do it. But I guess in this case, I'm gonna to play around. Otherwise, maybe we'll figure out why. But and then otherwise best is equal to 0, and that only happens when RNC is equal to 0. And then I think this is roughly it, minus potentially an out of bounds because I'm being careless somewhere, or there's a typo somewhere, but let me double check. Yeah, I mean, I guess in theory I should check that this is 0, but maybe that shouldn't happen. I mean, I guess that's technically possible if you have, but cool. It's slower than everyone. Huh. Wonder why that is. I mean, can't really do much faster than looking at every element once. So I'm not gonna concern with it that much. Maybe it's just a timing thing. Um, it's a little weird though. Maybe I'll take a look later. Um, but yeah, I would say, yeah, it's n squared or m times n, depending on how you want to define it, but it's linear in terms of the input size because you look at each cell once, and you can't really do any better because you have to look at each cell once. Maybe it's all these if statements, but I don't think that is a big deal. And you could probably write this in a, like I said, if I didn't try to do this in place, I would have had a boundary, and that makes it a little bit less edge casey, which is always nice. There's definitely too many edge cases, and it makes it more a little bit error prone, but it's technically still correct, but that's fine. Yeah, so the running time is going to be linear, which is n times m, or m times n, or number of rows times the number of columns, and the space. In this case, I don't use any extra space, technically. I mean, but it's technically all of n times m squares because you should not use the memory that someone give you an input necessarily. But either way, it's fine. However, as long as you kind of mention those caveats to your interviewer. I think this is a relatively I mean, yeah, okay. It's fine. I mean, I'm not trying to, you know, it's fine. But sometimes maybe the server is slow or something, or a lot of people are on. But yeah, I mean, I think this is a relatively I wouldn't say straightforward. Maybe that's not the right word, but it is a relatively textbook application of dynamic programming / maybe some sort, depending on how you do it, is the shortest path in a graph from the bottom, or sorry, from the top left to the bottom right, right? So you could definitely model it that way. I like to do it this way because it's just 2 for loops and relatively clean, even if I could have done this slightly differently. But yeah, I mean, I feel like I've definitely seen people give dynamic programming problems on interviews, at least in the past. I feel like that's been a little bit out of what you may call it, like it's not in style anymore. But this is a very basic one, regardless of how I feel about it, or dynamic programming on a contest in general. Sorry, on an interview in general. So even though I rarely see grid-related ones that are on graph problems, it's still basic enough that I would kind of get familiar with it, because there are definitely stuff that are related to this that only gets harder, and they will be on interviews and stuff like this. Yeah, so Dunkin' Donuts is asked which part is dynamic programming specifically. So I mean, I think sometimes dynamic programming is a word that gets thrown, or 2 words, I suppose. It's a phrase that gets thrown around a lot, and I think it is easy to kind of because sometimes you think about, so a core part of dynamic programming problems is that it relies on the what they call a suboptimal, or sorry, an optimal substructure, which is another way of saying like having subproblems that reflects the solution, that you can, like having subproblems where the solution you could build on top of in a intuitive, or not intuitive, just in a greedy way, greedy-ish way, choosing between different components and stuff like that. And because of that, you can think about, and this is an example of bottoms up dynamic programming, which usually looks like for loops, so sometimes it is very deceptive in that way. But if I had implemented this in a top-down kind of way, right, then it would kind of be more intuitive why that is the case. But the intuition between this is that, okay, for each cell or C or comma C, what is the best way to get here, right? Well, the best way to get from so okay, let me just leave a comment. So grid sub RC is equal to the cheapest or minimal. I mean, cheapest, same thing, I guess. Minimal cost to get to RC from 0, 0, right? So you could kind of think about this recursively, and then you'll be like, okay, well, the best way to do this is to answer this question is that the grid of RC, R comma C, is well, the cost to get from the one, R minus 1 walking down, or C minus 1 walking right, or something like that. And then, well, what's the cost over there? So you kind of keep asking those recursive questions, right? And then that it just so happens that because of the way we did the for loop, those answers are already answered, so you don't have to kind of repeat them. And that's kind of why it's dynamic programming, because you can imagine that sometimes that's not the case, and maybe in this for loop, and because it's a DAG, there is some like thing that you do something similar to a breadth first search / shortest path in a DAG type thing, and that allows you to kind of have some intuition for this for loop, and you may not explicitly think it's a dynamic programming problem, but that's how it works out. And I would also say that for a lot of dynamic programming problems, you could rephrase it as shortest path in a DAG, and sometimes it's more obvious, sometimes it's less obvious. Well, maybe for counting ones it's not, but for like if you have a problem, it's like, okay, get the minimal cost of whatever. Well, very often that's like the shortest path in a DAG or something like that. So that's so you could think of like another way of thinking about dynamic programming problems is that you have all these what people call in general, not just me, states, and then you have like these edges that so those states are kind of like a node in the graph sense, like a vertex in the graph sense, and to get from one state to another state, which is from one vertex to another vertex, there are these edges, and then those edges has a cost, which is the weight in a graph. And in dynamic programming, if you do the ordering of these states correctly, then it will always be a DAG. Otherwise, you have like this circular thing, right? And then in that sense, it becomes a shortest path in a DAG. So that's the intuition between that, and that's kind of why I say this is, or like why this is dynamic programming, even if sometimes it's a little bit like it doesn't feel like it's dynamic programming when things look so simple. But there's a lot of kind of theory behind that foundation, and yeah, and that's just something that I would think about because that allows you to, like, if you build the right foundation, and that's how you can extrapolate to more complicated dynamic programming problems and so forth. Cool. I'll answer your question in a sec, but okay, you can ask different cues related to the solution. Yeah, yeah. I mean, I think there's things you can ask about it, but yeah, that's all I have for this problem. I think hopefully that's a good enough explanation of dynamic programming, because I think a lot of people have issues with dynamic programming, and I don't know what I necessarily want to go with that, but it's just something that I find to be like just something that's hard, right? Dynamic programming is hard. I think that's as much as I could say about it. And I have like many years of experience per se in terms of programming dynamic programming problems. A mouthful. And if you go back to like my YouTube videos, for example, like there was like a week where I only did dynamic programming problems because like I was rusty, and even I had trouble with it. That's what I mean. So like, there's no shame in it, in general. But just try to figure out what to learn about it.